Okay, welcome back. In this video lesson, what we're going to do, let's make sure this is running, yeah. We're going to talk about the rules for biconditional. And namely, this is going to be biconditional introduction and biconditional elimination. And the biconditional elimination is actually relatively simple, and it's very similar to a rule that we've already seen, augmented just a little bit differently. So it'll be kind of like conjunction elimination. So hopefully you'll see it. So the idea here is you have a sentence that says, look, P if and only if Q. And then you get the sentence P. Well, what that allows you to infer is Q. And this will be, the justification we'll use for this is going to be biconditional elimination on these two. But hopefully you'll notice that it doesn't actually matter whether or not it's P. It could have also equally have been, so if we have this iterated right here again, a little bit too lazy to write. So if we had it like Q instead, then you could actually infer P. So it could go either way. The idea is just if you have a biconditional and you get one of the components of the biconditional, then this rule allows you to infer the other. So yeah, and actually before I do an example, let me then give you the biconditional introduction. So let's just start this again. Let's see if we pick up this colors. Yeah, you should be able to see that. Okay, biconditional introduction is a little bit more subtle. So for biconditional introduction, you need to use two subderivations. So you need to make an auxiliary assumption, namely like P, and you need to show that from that auxiliary assumption, Q holds, right? And then you might have a bunch of lines in here, you might have a bunch of subderivations that are embedded in one another. It always depends, but the very minimal thing you need is you need to have a subderivation with P as your auxiliary assumption and Q as the end of the derivation. And then you also need to have another auxiliary assumption, not in addition to this one embedded, but on its own. So we've closed off that subderivation, and this time we're going to assume Q as our starting point. And we want to show that from having assumed Q, you can actually derive P. And what the biconditional introduction says is if you're able to do these two, right? So if you're able to do a subderivation where you assume P and you get Q, and you can do a subderivation where you assume Q and you're able to get P, then you're allowed to infer that P, if and only if Q. And then what you would cite are these two subderivations. And that's going to be our biconditional introduction. So why don't we go over an example, and I'll just make one up here. So suppose we have one assumption, if A, then B. Suppose we have another assumption that says if B, then C. And then we have if C, then A. Okay, and what I want to derive is, so my goal here is going to be A if and only if C. That's my goal. So I'm going to put that at the bottom. That's going to be my goal. I say if A if and only if C, and the justification I'm going to use is the biconditional introduction. And so before I even think about how to do this, right, I mean, you can think that we always need to be working backwards from the goal, right? Always, in most of the times, actually, it's really helpful to always think backwards. And sorry, I don't mean to be, these aren't meta variables here. These are still just A and C. I just wasn't happy with the way they were looking. So we need to work backwards, and our rule for conditional introduction says that you need to have two subderivations, right? One in which case you assume C and you try to get A, and the other case where you assume you have A and you try to get C. And we've already done a lot of the work in this case for doing the proofs that we need, right? So and a lot of times you might think, oh man, how am I going to possibly get this? Well, just think about what the rule is and work backwards from there, and just set up the schema before you even really look at what's going on in the primary assumptions. And by doing this, you'll actually help yourself a lot in terms of the setup. So now all we need to do is figure out, how do I get C, right? I'm assuming A for the, I guess I should maybe write this. We're assuming A for the purposes of biconditional introduction. Just make that clear. And here we're assuming C for the purposes of biconditional introduction. And, you know, if you want to be funny, you can see that I wrote a certain word here that might be bad. But in any case, so now in this subderivation, we need to go get C. Where might we be able to do that? Well, we see that C is the consequent here of this material conditional. So we want to see if we can get C out. But in order to do that, we need to get B. And up here, we see that B is the consequent of this conditional, and we need to get it out by finding the antecedent A, which in this case, we actually have. So given that we have A, and given that we have if A, then B, we can actually use conditional elimination to actually derive B. So we can derive B, use conditional elimination, and the lines that we need to cite are 1 and 4. And then we need to try to get C, and the reasoning, the backwards reasoning we did was we wanted to get B so that we could try to get C from this material conditional. And now that we have B, we can use conditional elimination again using lines 2 and 5. Right, so we have line 2 and we have line 5, so we have the antecedent of the conditional, and then conditional elimination allows us to take out C. So we've actually finished this first subderivation. Now all we need to do is get A in the second subderivation where we've assumed C. And this one's actually relatively easy, right? We have C here as our auxiliary assumption, and here we have a conditional with C as the antecedent. So we can actually get A by using conditional elimination. And we need to cite line 3 and 7. And that's it, right? That was the thing I need to derive in the subderivation. So now that I've gotten this, I fulfilled all the requirements for using biconditional introduction, and what I do is I cite lines 4 to 6, and I cite lines 7 to 8. And so this is an example of how you would use biconditional introduction.